So in this question here, I've got a box being pulled at an angle of 65 degrees with a force of 2,500 newtons. Now the coefficient of friction is given as the Greek letter mu, which is 0.33. What is the mass of the box for everything to be in a state of equilibrium? Now to calculate this, first of all, I'm going to draw a forces diagram. So I'm going to represent my box and call the mass of it with the letter M. That's what we need to find, is that mass. Now I'm going to draw in my forces. So I'm given 2,500 newtons at 65 degrees. So let's just put that one in there. So that's quite a big force. And the angle, 65 degrees. Okay, now what we want to find is the other forces that are acting on this box as well. Well, one that's always going to be acting on the box is the force of gravity. So the gravity acting on this box will be M, which is the mass of the box, times G, which is the gravitational constant, 9.8. Okay, so now let's draw in the other forces that will be acting on it to give us a state of equilibrium. So we'll have a force here, which I'm going to call R, which is our resulting vertical force, which will counteract the forces acting on this. And there will also be a force which I'll call F, which will be the horizontal force counteracting all the forces going in the right hand direction. And then what we can set is, with the coefficient of friction, F will always be less than or equal to the coefficient of friction times the force R to be in a state of equilibrium. Okay, so now from that we'll be able to extract the mass of the box. Okay, let's calculate the force F. So F is going to be set as the opposite of whatever's going in this direction. So whatever this is, we'll have an equal force going in this direction. So if we draw a triangle on here and make a right angle, we can use trigonometry because we need to find the magnitude of this force here. Now, as it's adjacent to the cosine to 65, we can use cosine. So force equals cosine of 65 times this force here, which is 2,500. That's the magnitude of our force. Now we need the vertical force, which is R. So R will be this force here, which is M times G, and then subtract that from whatever force is going in this direction. Now using trigonometry again, as it's opposite, we'll use sine. So minus sine of 65 times 2,500 newtons. Okay, right. Now let's have a look what we got here. We need F to be less than or equal to mu times R. So F will be less than or equal to, mu is 0.33, and then we'll multiply that by our force R, which is mg. Well, G is 9.8, so I'm going to put that in already. 9.8 m minus sine 65 times 2,500 newtons. Okay, well F is cosine 65 times 2,500. So I'm going to write that as cosine 65 times 2,500 less than or equal to, now let's distribute this 0.33. So I'll have 9.8 over 0.33 m minus sine 65 times 2,500 newtons over 0.33. Okay, that's not right, is it? So 9.8 times 0.33, so 9.8 times 0.33, and that'll be giving me m. And then I need 0.33 minus sine 65 times 2,500. So minus 0.33 times sine 65 times 2,500. Okay, now let's get m on its own. So bring this over to this side. So now I'll have cosine of 65 plus this plus 0.33 times sine 65 times 2,500. So let's put that in a bracket so we distribute the 2,500 with everybody. Okay, and then that's going to be less than or equal to 9.8 times 0.33. Okay, and that's going to be multiplied by m. Okay, so now to get m on its own, I just need to divide everybody by this 9.8 times 0.33. So now I'll have m is greater than or equal to 2,500 times cosine 65 plus 0.33 sine 65, and then divide that by 9.8 times 0.33. Okay, let's plug that in a calculator. 2,500 cosine 65 plus 0.33 times sine 65. That comes to 1,800, and then divide that by 9.8 times 0.33. So that comes to 557.9. So that's approximately 557.9. Okay, so that's going to be the mass of our box. So therefore the mass is going to be greater than or equal to 557.9, and that's in kilograms. And that's the mass of the box we need for everything to be in equilibrium. Okay.